words. And now all of you already know what these, you have seen these words, but you might not be aware of them in a mathematical setting, except for that first one. You all know what a set is because you have all in English class done these, right? When you have the characteristics of the bad guy and the characteristics of the good guy, and then they overlap in the middle, the Venn diagram, and sometimes there's characteristics of a third person. Right there is where they all overlap. So you all already know what a set is. So what it means in math is a set is any collection of data. Now I say data, some of you say data, it doesn't matter. Any collection of data. And data in math, I'm going to do that thing where teachers use a word and then they put another word in the definition that needs another definition. Data is anything that can be counted. Okay? If I count something, I have a set of data. As soon as I start counting another thing, I have another set of data. Everybody cool? All right. So, look around this room. What is something that you could say would be a set of data? Nathan. Excellent. People in the room would be an excellent set of data. Everybody agree? Can we count the people in the room? Of course we can. So we could have, I'll write example, and Nathan said people in room. Agreed? Okay, can anybody give me another one? Riley. Desks in the room. Another good one. Excellent. Okay. So everybody is aware, chairs in the room, walls in the room, whatever, right? Okay. Can I break this set down into subsets? What would be the logical breakdown of people in the room? Or one logical breakdown of people in the room? Rylan. You could do that one. What else could you do? Okay, you could go by some sort of racial characteristic. What else could you do? Pardon me? Height. Excellent. Okay, what else? Well, you said color.
He said color of clothing.
Oh, did you?
Yeah.
Well, I'm sorry. I thought it was a weird one for you to say. Excellent. Color of clothing. Better. What else? What else? There's a pretty obvious one that nobody has said. Rylan had gender. Eye color, hair color. Good ones, good ones, good ones. Shoe size. Okay. All right. I was going more kids and grown-ups type of thing, but okay. Everybody cool? Everybody understands what a set is? And if you can count it, you have a set. Can a set have nothing in it?
No. Yeah.
Tajir says no. Nathan says yes. How many adult women are in this room? Zero. So can we have a set with nothing in it? Excellent. Okay. Can a set have one thing in it? Can you count one thing? How many chronological adult men are in here? One. Actual way that adult man behaves, you might argue, is not necessarily adult, but that's another story for another day, right? Okay. So we're all good with sets, yeah? Okay. An element is a single, please underline single, highlight single, do what you need to do, a single piece of data in a set. Now, the proper word there, single piece of data, I know none of you, or very few of you probably know this word. There is a word for single piece of data. It is a datum. D-A-T-U-M, because data is a plural word, but people don't know that. So I write single piece of data. Technically, all I need to write is a datum, but then everybody says, what's a datum? So I don't write it, then I have to explain it all. So it's a single piece of data in a set. Everybody cool? So a set is everything you count. An element is each single thing in that set. Yes? All right, so the easier set to use this to explain is grown-ups and kids in this room. How many elements are in the set of grown-ups in this room? 1. How many elements are in the set of kids in this room? 30 of you if you were all here. Easy peasy lemon squeezy, right? We all understand it, yeah? If you can count it, it's a set. Each thing in that set is an element. Everybody cool? Okay. A relation is when we compare one set to another set. So, when I was asking for some other ways to split up the people in the room, somebody said hair color. Right? Okay. So, if we were comparing hair colors to people in this room, that would be a relation, yes? Because everybody in this room has a hair color. But there are only how many hair colors that we could have in this room? What would you say are the hair colors that we would have in this room? Yeah, right? There's not that many, are there? There's not as many hair colors as there are people. But hair color is the second set, isn't it? Because in the first set of people in this room, there's 30 of us, right? For lack of there isn't actually 30, but you know what I mean, right? And then for hair color, there aren't 30 hair colors, right? I mean, what are the hair colors we traditionally say? Black, blonde, brown, red, right? Oh, and old fart color, gray, right? So there's 5 hair colors for 30 people. 2 different sets, yes? 2 different sets of elements. One of them, hair colors, have 5 elements, the 5 colors. The other set, people in the room, 30, because there's 30 of us. Everybody cool? So as long as we are comparing one set to another set, we have what we call in math a relation. All right? Everyone's good? Okay. So here is a graph. In math, to do a graph, you need to have 5 things to get full marks and have a good proper graph. What are those 5 things? No. Well, if you're not graphing dogs, then you wouldn't have dogs on your graph. What are the 5 things every graph needs? Give me one, Sacho. It needs a title. Give me another one. Tajvir. Pardon me? You need some kind of scale, yes? How are we counting it, right? So we need a scale. Now, on a graph, it's always counting how many sets, at least. Kaylee. Oh, you're moving on to the second thing. Yes, absolutely. Fine. No, that's cool. You absolutely need that. You need titles of your sets, right? What are we putting on the graph? Then, obviously, we need some data. 1, 2, 3, 4. What is the one other thing that you would think a graph would need? We need some sort of presentation of that data, yes? This happens to be a bar graph, what you guys would call a bar graph, right? Everybody cool? So we need data on the graph, and then we need the presentation of said data. Now, data, not date. Alrighty. So we're all good here. Now, down here, what are these things? Excellent. They're breeds of dog, yes? Are these elements, sets? What are they? They're elements, right? What is the name of the set? Right. So down here, I really should have type of dog, shouldn't I? Because that's what Kaylee was saying. I got to tell you what I'm doing here, right? These could be names for all you know, right? What if you don't speak English? Somebody gives you this graph. You think some dude's name is Chihuahua, right? So you got to name it, all right? Now, what's up here? These are just numbers. That's the height, right? So I got to say over here, height. Now, Tajvir said I need numbers, yes? And I do need numbers. But what do those numbers mean? The dog height in what? In Kaboobly Heinz's? Inches? Your hound is 60 inches tall? That's a 5-foot dog. Feet? Your dog is Godzilla. What is a sensible scale here? Centimeters, right, okay.
Are you telling me that Chihuahua is like this big?
Tall. Tall.
Oh, okay.
Average dog height. And really, if I had my way, hell yeah, I wouldn't even talk about Chihuahuas because they are not indeed dogs. They are not even rats. Rats can survive in the wild. A Chihuahua can't. Genetically speaking, Nicole, yes, indeed, a Chihuahua is a dog. If we were to take a cell out of a Chihuahua and compare it beside a real dog, the cells would be the same. I agree with you completely. But in reality, their genotypes, yes, they are both dogs, but their phenotypes, a Chihuahua is no dog. Right? A Chihuahua is breakfast for a mean cat. I know some of you like Chihuahuas. I apologize that you like Chihuahuas. I'm sorry for you. You're entitled to that opinion. Everybody can have an opinion, even when they're wrong. Does anybody in here actually have a Chihuahua? Like, honestly, you're not being a chump. Does anybody have a Chihuahua? I apologize if my feelings of Chihuahuas are affecting you in any way, like making you sad. It's okay. All right? I don't like them. I also don't like min pins. My sister has a min pin. I don't like them either. Corgis? Yorkies. I don't mind a Yorkie. I can get behind a Yorkie. What do you got? Chihuahua min pin. That's the evilest dog in the world. It's, of course it bit you because little dogs are a-holes. If a big dog behaved like a little dog, everybody would make them be put to sleep. Wouldn't they? You all know this. If a big dog came up to you the way every little dog, I'm going to tear out your eyes, mother. You would run screaming and say, oh my God, get control of your dog. But when it's a little dog, the person says, oh, he's just little, and picks him up, and it's like, it's okay because he's little. Screw that. If your little dog bites me, I'm kicking that dog into next week. Yeah. No. Little dog people that think their dog's allowed to do whatever they want and carry it into the store, reach over the carrots while your dog drools all over the carrots. Oh, he's just little. It's okay. Shut up. I'm going to bring my Chihuahua on the plane. Screw you. You are not. Or I'm going to bring my dog on the plane. My dog weighs 90 pounds. Anyways, I got a thing about small dogs. Maybe you've understood that from my speaking right now. All right, so here we go. Let's learn some math here. Set 1. What is one of the sets that we are to count? What is one of the things that is being counted here? Dogs. Set 1 is dogs. What are the elements of that set? Yeah, so what are they? Hound, Chihuahua, which pains me to write, Corgi, Lab, Shepherd, and Malamute. Right? Those are, the set is dogs, the elements are the actual dogs. Everybody cool? All right, what's the other set? What's the other thing that we have counted? Height. Excellent. And what are the elements of that set? The numbers. And what are they? No. 60. Little bit more than 10, right? Okay, 12, 30, 45, 45, and 80. Is everybody cool? Right? And now we have a relation, yes? Because we have compared one element, a hound, to another element, a height. And hounds are 60 centimeters tall. Is everybody good? Everybody understands? All right. Now we're going to be flipping back and forth between these two pages. So don't do what Helia just did. There we go. Yeah, do that. She folded the page over, and I need to go back and forth. Okay? So, Is this a relation? Have we compared two sets? Yeah, we have, haven't we? Okay. So now, first thing we're going to do is turn the page over. We're going to learn what a function is. That's a new word. A function. A function is a special relation. Okay? What's a relation? Anytime you compare two pieces of data. But there is one kind of special relationship that we call a function. And a function is a special relationship in which each element of each set relates to only one element in the other set. So I'm going to let you write that down, let it sink in for a minute. I'm going to leave it on the screen for a sec. If you have, anytime you compare two things, you have a relation. Sometimes that comparison is special and it's a function. Now you're not going to do any writing for a minute, but we're going to turn back over to this page. All right? Now, I'm going to erase some of this ink because I don't need it here. All right. Now, is hound an element?
No.
Yes. Is 60 an element? Does hound in set 1 relate to only one element in set 2? Yes, because the hound is 60. Everybody understand? So if all of this wasn't there, is that a relation? Is it also a function? Yes, because one set relates to one set. Agreed? Okay. What if I add just Chihuahua? Pretend all this isn't there. Is it still a function? Why? Yeah, hound is 60, Chihuahua is 13. We cool? What if we go just to Corgi? Still a function? What if we go to Lab? Still a function? What if we go to here? No, why not? Because now Lab and Shepherd have the same. Does everybody see that? Everybody understand? If I say, how tall is a Lab? Can you tell me the answer? How tall is he? 45. Good. If I ask you, what dog is 30 centimeters tall? Corgi, you can do it, right? Okay, because it's a function. Once I add Lab and Shepherd, I'm thinking of a dog that's 45 centimeters tall. What dog am I thinking of? You don't know, do you? So it's a relation. Does everybody understand? Okay, I'm going to give you another one that has no picture in front of you. See if you can work it out. Remember the other one we were talking about, people and hair color, yes? Is that a function or a relation? It's a relation. Why?
Because a lot of people have brown hair.
A lot of people have brown hair, a lot of people have black hair, a lot of people have blonde hair. The only way that would be a function is if we did red hair, wouldn't it? Because how many redheads are in the class? 2. Jaden. So Jaden, that's a function, right? Everybody understand? Jaden is one. Nathan's not a redhead. Come on. No, he's not. That isn't red hair. What, you people know all your colors from paint stores where there's 85 colors of white? That's not red. Jaden is a redhead. Nathan's blonde. Yes. Yes. Bah! Go away. It bothers me that there isn't a good punk kid in this class with like green hair or blue hair or something like that so we could really do it. But there isn't, so we'll carry on. Nicole's natural hair color is green? Oh, I see. Okay, here we go. Let's see if you understand. Turn the page over to 144 and let's see if you get it. Each month of the year relates with the number of days. First of all, what is one set? What is set one? Months. Excellent. What is set two? Number of days. Agreed? What are the elements in set one? Jan, Feb, March, and so on. Agreed? What are the elements in set two? No. 30, 31, 28, or 29. Agreed? Okay. So those are the two options, yes? How many days does January have? 31. One piece of data relates to one piece of data. Function or relation? It's function right now because 1 to 1, right? What's February? 28 or relation or function? Relation, because February could be one of each. Everybody understand? Yeah? Yep. Everybody cool? And then March is what? 31. So that makes it a relation again, right? Because I could say, I'm thinking of a month with 31 days. You know what month I mean? So you can't do it. All right? Well, you still couldn't do it because there's 28 or 29 days in every single month. Ha-ha! See what I did there? Hey, see if you guys can figure this out. I was born on February 29th, 1980. How many birth dates do I have?
3. No?
I was born on February 29th, 1980. How many birth dates have I had? I've only had one, haven't I, Gurjap? Why? Because I've only had one birth date, February 29th. How many birthdays have I had? Divided by 4, right? It's a little brain teaser, relax. Last leap year was 2016. 2020. Summer Olympics happen on leap years. Yes, really. Is everybody good? All right, let's try the second one. This one's a little trickier. Every name on my class list relates to a student in the class. So what is set one? Okay, the names. What is set two? The actual students. Now this is where it gets tricky. On my class list, do I have first name, last name, both? What? Both. So on my class list, I have a first name and a last name, and I look out and I see you people. So I got firsty, lasty, right? And that kid right there. Kid A. Does that first and last name relate to anybody else? No. Right? In this room, it doesn't, does it? Because we have no kids in the room that have the same first and last name, do we? So if I use first and last name, is it a function or a relation? Function. Because one person has that first and last name, yes? Everybody understand? What if I only went by first name in this class? Still a function? Or is it a relation? Still a function. Why? Because nobody has the same first name, right? What if I went only by last name? That's a relation. Why? Do any of you share a last name with anybody else in the room? Not in this room, but could it happen? Yeah, because what if I was going by Gill? How many Gills are in the school? A lot. What if I was going by Smith? Yeah, in this school. There'd be more than one. Robertson. There'd be more than one. Everybody understand? Right? So if I go by first and last, I'd be okay. Now, one year when I did this course, I had both Jasreet Gills in my class. No. There are two girls in grade 11 in this school who are both Jasreet K. Gill. Even middle name was the same. So in that class, huh? Oh, okay. That's something new to me. I did not know that. But all right. They were both Jasreet K. Gill. And they were in the same room. It actually made this question good because I could say, what if I went by first name and last name? All the kids say, it's a function. Like, really? It's a function. Then they get all mad at me. Really? It's a function, Mr. Myers. Don't be stupid. What about those two? And they were like, oh. All right. So we're all good? Everybody can do a function versus a relation? Yeah? Okay. New words. Dependent variable. Independent variable. Okay. First of all, I need to talk about what a variable is. We all say it's something unknown. That's the first thing everyone says. The next thing most people say is X. Right? Okay? Everybody cool? No. A variable is any value that can change. So, looking up at our previous two examples, I have a class list, yes? The set is names. But are all those names the same? No. So the name can change. So it's a variable. Everybody understand? The students, are any of you the same as one of the other kids in here? No. So you change. Everybody understand? That's a variable's real definition in math. It's something that can change. All right? Okay. So now we have two kinds. We can have a dependent variable or an independent variable. What does the word dependent mean in English? Something else has to happen, doesn't it? For that to happen, right? And what does independent mean? It can happen all by itself, right? Everybody cool? All right. Is a grade on a test for you independent or dependent? Because grades change. It is dependent. Why? You have to write the test first. Does everybody understand? So on your report card, your marks are a comparison of the tests you write against your scores on them, yes? The tests change. You've written 4 tests, yes? So is that a value that can change? Right? Your grade depends on your tests. Everybody with me? Everybody understand? Okay. So the dependent variable, as Nathan told us, is the variable which cannot stand alone. Right? If I say to Helia, 94, does that mean anything? Right now we're talking about grades, but if we weren't talking about grades, what could 94 mean? You have no idea, right? It could be 94 seconds. It could be Helia has 94 Beanie Babies in her room that she doesn't want anybody to know about because Beanie Babies aren't cool anymore.
94 days left.
Okay, everybody understand? 94 days left till what, Rylan? Okay, Ryland's gone dark, everyone. Let's support Ryland for the next little while, because he seems like he's in a dark place. All right, everybody with me? It's the thing that changes that cannot stand by itself. Okay? Everybody good? All right. So let me give you an example. There's a kid, right? Right? Everybody understand? He's a student in the class, yeah? Yeah, I know. They're not even saying yes now. Yes. Okay, let's try this again. That's a student, right?
Yes.
Okay, now, let's pretend we don't know who he is. Is he still a student?
Yes.
Yes. So he would be that person sitting right there. Would he be dependent or independent? Independent, because he's right there. Now, if I told you there was one student in this class, only one, and that student's name was Sam Sahota. Sam Sahota is dependent on the fact that he's the kid that's here. Everybody understand? Okay. Everybody is good? All right. So then, obviously, the independent variable is the variable that can stand alone. And I like to think of it as the independent variable is the variable that's the same for everyone, regardless of data. Now here's what I mean. That kid right there, that student, has an age, has a height, has a grade in this class, has a hair color, has an eye color, is wearing shoes, everybody understand, right? But regardless of what I am counting, hair color, grades, age, whatever I am counting, he's still that kid. Does everybody understand? And you are all the kid that you are. No matter what else I am counting, you people are you people. Everybody with me? That makes you the independent variable. Everybody good? Okay. So, don't bother turning back. Which of these is the independent variable? The variables are types of dog and height. Which is independent? The dog, right? Because no matter what else I'm counting, if there's a chihuahua right here, and it's not going, rah, 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 and I'm not tempted to kick it into next week, if there's a chihuahua right here, regardless of what else I count, there's still a chihuahua here. Everybody understand? Okay. Now, back to where we were. Dependent variable, independent variable. Now, the domain. I'm highlighting it in green. Why do you think I'm highlighting it in green? Because I screwed it up. Sorry. I'm highlighting it in blue. Why am I highlighting it in blue? It's related to the independent variable. The domain is the set of data I shouldn't have said set of data. It's the, sorry everyone, it's the elements that make the set of independent variables. All right? So, in this room, we've already established you people are the independent variable. So the domain is each one of you, because you're the elements. Everybody understand? Kid A, kid B, kid C, kid D, you're the domain. Everybody cool? So what then, obviously, duh, is the range? Yeah, it's the elements that make the set of dependent variables. Is everybody cool? Now, there's a couple of ways to recognize these things, but you need to know the definition, because depending on how you make a graph, they can change position. All right? Generally, domains are what we consider X values or what we consider inputs. Ranges are generally Y values and what we call outputs. Now that input-output thing, that comes from like grade 3. Think back in the day. It might be grade 6. But think back to your old math textbooks and see if you can remember a drawing that looked like this. And then a little belt. And then a different shape. And that had +7. And then a little belt. And then a different shape, and that had -2. And then a little belt. And then the same shape here with this. And you dropped in a 7, input 7, +7, 14, -2, 12, and you output 14. Have any of you seen that sort of construction before? That's a mathematical function, because I input 7 and I got out 14. No matter what number I put in here, will any other number get me 14? No. No other number will get me 14. Because if I put in 8, it's 8 plus 7 is 15 minus 2 is 13. Picking up what I'm putting down? That's where that input-output thing comes along. Is everybody still cool? All right, let's try to apply that new knowledge. Turn the page over. Sandy's getting a job at Flying Wedge Beach. She's paid $9.50 an hour. You can tell how old this is. Minimum wage is no longer $9.50 an hour. Yes. Her work hours are related to her pay per week. We understand they're related, right? Because the two things we're counting are her hours at work and her pay. So as soon as I'm comparing two things I count, I have a relation. All right? Everyone agree? Okay. So now, let's do the IV and the DV. The IV is what? The hours worked. You're exactly right, Kaylee. Why is it the hours worked? You're very close. It has to do with her and hours. Nathan? Not quite.
You don't know how many hours she worked?
Getting warmer. She's paid depending on how many hours she works. Right? Everybody understand? Now, the other definition I said, it's the one that's the same for everybody, right? Are we all working at Flying Wedge right now? No, we're not. Flying Wedge doesn't even exist in Abbotsford anymore, which is too bad. It's really, really good pizza. There was one. It was over by the Shoppers Drug Mart, by Original Joe's, and that weird olive store. Like a store that only sells olives. Like, I know, right? Like, come on. I'm aware that there's two of them in Abbotsford. It's weird, right? Like, is there that much demand for olives? Apparently. Anyways. I digress. Are any of us working at Flying Wedge right now? No. Are hours passing for us? Yes. So because an hour is passing for everybody, it's the independent variable. Everybody cool? The IV is the time. Now, please remember, the hours aren't the independent variable. The hours are the unit that we count the independent variable in. The independent variable is time. Everybody good? Now let me give you a little hint here. Put a little star. If time is one of your variables, time is almost always the IV. Almost always. So then obviously, what's the DV? Her pay. Because pay depends on how many hours she works, right? Now, identify the domain and range. Now, this is going to get a little tricky. We have to do some pretending here. Sandy can only work whole hours. Okay? We're going to pretend that the laws don't exist and she's allowed to work 1 hour. Everybody with me? So, the domain and range. What are the elements that make up the domain? What are the values that I can give for a domain? The domain is the set of independent variables. So what is the lowest amount of independent variable I can work? Right. No. 0. Everyone agree? I didn't go to work that day, so I'm not going to get paid. Cool? Then what? Then 1. Then what? 2 up to a maximum of what? She could work 24 hours in a day?
8.
There are 24 hours in a day. So let's keep one law. Maximum she can work is 8. Okay? Does everyone agree? Yeah, you could do overtime, but then you'd be paid more than $9.50, so this data wouldn't count, right? You actually stole my very next sentence. Stop it. Get out of my head. But, if you want to mess around in there. It's a little spacious, though. There's a lot of empty space up there. And more daily, I've noticed. So what's my range? Mm-hmm. If I don't work, 0. If I work 1 hour,
950.
950. 2 hours, 19, right? 3 hours, 2850. 4 hours, and so on. Everybody cool? I don't want to do the math. Everybody understands though, right? Okay. Is it a function, yes or no?
Yes.
It is a function. Why?
Because one, like, how, based on how many hours you work, you get paid, like, that much.
Right. Whatever hour I input will give me a unique output. Yes? If I work 5 hours, I'm working 5 times 950. If I work 3 hours, I'm working 3 times 950. Is there any way other than working 2 hours that she could earn exactly $19? No. With this data. There isn't, right? She would have to work 2, and if she worked 2, she's being paid $19. End of discussion. Right? So it's a function. Everybody cool? So why? Each hour input equals a unique output. Is everybody cool? Yeah? Okay. Let's look at the next one. As soon as you see numbers written that way, what are they? Coordinates, which means they are made up of what and what, Rylan? They are made up of x and y, correct? Okay. So which one of those, 1 or 3, is the domain value? X. So my domain is what? 1, 2, 3, and 4. Now, when we do this kind of math, we use funny brackets. We don't use this bracket because this bracket is for coordinates. We use these squiggly devil head brackets. Okay? You don't have to draw them well. I just do squiggles. So it's 1, 2, 3, 4. Squiggly. Because those are my domain values. Everybody cool? Okay, what are my range values? 3, 6, 9, 12. Now, please notice, we always write these in ascending order. What does ascending mean? Getting bigger. So even though 1 and 3 are a pair on the graph, they are not necessarily a pair here. Does everybody understand? 3 was the smallest range value, so it goes first. Everybody cool? What if I said the last point was 4, -7? Then what would be here instead of 3? -7. Even though 4 is with -7 as a coordinate, in our lists, we wouldn't put 4 with -7. Everybody cool? All right. So, we've got our domain and range. Is it a function? If I start at 1, I get 3. Do I get any other values when I start at 1? When I start at 2, what do I get? When I start at 3, what do I get? When I start at 4, what do I get? So that is a function. Because each input gets me a unique output. Everyone agree? All right, let's do the second one. What is my domain? -1, 0, and what? 1. Why didn't I write 2 zeros? Because it is the input. The input is 0. Right? What then is the range? What's the lowest range value? -1. Then what? 0, then what? 1. Now, is it a function? When I input -1, right there, I'm going to highlight, are there any other -1s? No, in the inputs? No. So negative 1 gets me one output, yes? So if I only am counting negative 1, is it a function? Yes. Okay, when I input 0, there's a 0, there's a 0. When I input 0, I get how many outputs? 2. I get 1 and negative 1. So because I have 2 outputs, when I say 0, you don't know if I mean the 0, 1 or the 0, negative 1. Everybody understand? So what's this? This is a relation. Because 0 could be 1 or it could be negative 1. When I have x for a 0, I have 2 options for y. And that's not okay. Everybody understand? Everybody cool? All right, you guys do C. Okay, what's my domain? Who do we appreciate? Math, math, rah, rah, rah. Go for Myers. Sure. Okay. Hell yeah. Office. What's my range? 3, 5, 7, 9. Now, these happen to work out as pairs, yes? Do they have to? No. Because I always put these in ascending order, right? Function or not? Yeah. Function. Why? No x gives me multiple y's. No input gives me multiple outputs. Everybody cool? All right. What's different in D? It's a graph with points on it, right? What do we know about every point, Kaylee? That point right there has 2 parts to it, yes? What are they? Don't give me the answers, just what are those 2 parts? Yeah. There's an X and a Y, isn't there? Absolutely correct. So isn't this the exact same as this, but on a picture? Yeah. Great. So what are my X values here? What is my domain? My domains are only my X's, yes? Yeah. Where do I find the lowest X value on a graph, left or right? Left. What's the lowest value on the left? Negative 3. Right there. What's the next one? Negative 2. What's the next one? 0. What's the next one? 1. What's the next one? 2. What's the next one? 3. Everyone agree? Okay. What about the range? Where is the lowest y value? Up or down? So what is it? Negative 3. What's next? Negative 2. What's next? Negative 1. What's next? What's next? What's next? 2. Now you will notice 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But they aren't lined up as pairs anymore, are they? Because negative 3 is not with negative 3, is it? Everybody cool? Now, let's check. Is it a function? Yes or no? No. Why? If I go to negative 2 on the x, what are my outputs? Negative 1 and negative 3. See? So I am thinking of negative 2. You all go to negative 2 on the graph. Now where are you going to go? Some of you will go to negative 1. Some of you go to negative 3. You don't know which point I am thinking of, do you? Everybody understand? But if I tell you to go to independent variable value 2, do you know where to put the dot? Yes, because you go out to 2 and you would go up, 1. Everybody cool? All right, now that, when you turn the page over, gives you this handy test. A vertical line test. If you've got a graph, any graph, okay? And you ever, please underline ever, touch 2 points with a vertical line, it's a relation, not a function. And here is what I mean. We're going to draw 2 graphs. X and Y, right? X, Y. Agreed? There's a graph, yes? Every spot of blue on there has an X and a Y value, yes? Right? So, over here I'm going to draw a straight black vertical line. Not too bad. Now watch. How many times does this black line touch the blue line at any given moment? Once, right? It's touching it right there. Now it's touching it right there. Now it's touching it right there. Now it's touching it right there. Does everybody see? It only hits the line once. So this is a function. Because no matter what my x value is, I only have one y value. Everybody cool? Now, what if the function looked like this? Function? Function? Function, 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 function. Now what? 1, 2, 3, 4, 5, 6. When x equals 6, how many outputs do I have? 1, 2, 3. So this is a relation. Does everyone understand? Now, let's look back at the previous one. We've already said that this is a relation, right? Based on the fact that at -2 there's 2 outputs, yes? Is this a graph? If I take a vertical line, I shouldn't use blue. If I take my vertical line and I slide it along, what happens right there? I hit 2. So it's not a function. Is everybody good? Okay. Now, I do apologize, ladies and gentlemen. There's a lot of stuff going on here. But we can't do the math with this unit until we know all this stuff. But we're almost done. And I'm not giving you any homework tonight. Is this a graph? Sure it is. I got points on it, yes? So, is it a function on? Well, as soon as it's on a graph, I can check with a vertical line, right? There's my vertical line. I'm just going to make these a little bigger because they're a little hard to see. Function or relation? Relation. Why? Because as soon as I move that black line, which won't move, what's going to happen? What's it going to hit? At -1 on the x, what's going to happen? I'm going to hit 2 at the same time, aren't I? Right there. Everybody agree? So this is what? Relation or function? Relation. Why? 2 outputs at -1 input. Is there another one? Where? You guys keep jumping to my next question, because my next question was, is that the only spot? And there's 2 outputs at +1 input. Everybody with me? Nathan. That wouldn't matter. No. So, now I want the domain and range. The domain are what values? X's or Y's. So what are they? -3, -2. Then what? 0, then what? Then what? Then what? So 1, 2, 3, 4, 5, 6, 7 domain values, but notice there's more than 7 dots here, yes? Right? Because these two and these two share the same input value. What's the range then? What's the smallest range? -2. Then what? Then what? Then what? Then what? Then what? And notice I have less range values. That's okay, because we're not counting pairs anymore, are we? We're only counting the X values, and we're only counting the Y values. Everyone cool? All right. What's different in the next graph? How does B differ from A? You guys have eyes. What's different? It's a different graph, and what's different about it? There's a line now, isn't there? Everyone agree? So first, let's check if it's a function. Is it? There's my vertical line. How many times does it touch the blue line? Once. So it's a function, right? All right, so we know it's a function. Now, this is where things are going to get a little different. You can all tell me what the lowest domain value is, right? Where is it? -3. Agreed? And you can all tell me the highest value, can't you? What is it? +3. Easy, yeah? But because it's a line, does it ever stop? Is there an input at -2 or -2.99999? Is there an input at -2.5? Is there a negative at -1 or an input at -1.75? Is there an input at -0.5? What about at 1? What about at 1.5? What about at 1.99999? There's always going to be an input, isn't there? So when it's a line, we have to write it differently, because we have to say that it's every single number between -3 and +3. So we write it this way: -3 less than x, because -3 is less than x, but x has to be less than 3. Does everybody see how that works? I have the lowest, less than, then x, then less than the biggest. Everybody with me? Now, think back to grade 9. Do you remember doing this? X +3 is less than 4. And then you knew that x was less than 1, right? And then your teacher said, put it on a graph. There was 1. You circled it and drew that line, right? Do you remember seeing that before? Okay. What did you do if that was less than or equal to 1? What did you do with that dot? You shaded it in. A shaded in dot meant it was included, right? Is that a shaded in dot? So did this line actually get to -3? Yes. So I need to put an equal sign there. Did it actually get to +3? So I need to put an equal sign there. Everybody cool? Easy peasy, right? So for the domain, we were only looking at the x-axis. Yes? Okay, well, what do we look at for the y? What do we look at for the range? The y values. So I'm going to look on here, yes? What is the lowest y value? -2. Did I actually get to -2? Is that shaded in? So it's got to be less than or equal to. And are we counting x's now? We're counting y's. And I went up to what? Did I actually hit +3? So I have to be less than or equal to 3. Is everybody cool? Now this is long and yucky, yes? That's a lot of writing. Math guys are lazy sacks of poo, aren't they? They don't write out anything. X times X times X times X, what do they write? X to the 4th. Math guys don't like to write that many numbers, so they invented another way to write this. This is called set notation. The other way is what we call interval notation. And that goes like this. It's still the same. It's still the lowest one, -3. Then you put a comma to the highest one. But you use different kinds of brackets. This 3 is included, so I put a square bracket. This 3 is included, so I put a square bracket. Everybody with me? So what then would the range be? Square bracket, because the 2 is included, -2, comma, then what? 3 with a square bracket. Everybody understand? Now, do you think I could use these with dots? No, because there are no inputs there, are there? So I can't use these because I could never color in the line. Everybody good? Okay, let's see if you can really get it. Turn the page over to 147. Is it a function? Yes, you can see that just by looking at it, right? We don't need to draw the line along. Now, this looks weird. Let's do the domain first. Where do we find the domain? On the x-axis, yes? What is the lowest x value? Look close. -30. Is -30 included? So what kind of arrow here? Less than or less than equal to? Less than equal to. And what are we counting? X's or Y's? X's. So I start there at -30, and then all the way up to here, there's an input all the way along, isn't there? So where does that end? -10. Do I actually hit -10? Look closely. No, why not? Because it's not shaded. So I need a less than 10. Is everybody cool? How would I write this in that other notation? Square bracket, -30, comma, -10, and then what? It's not included, so a round bracket. That is included. That is not. Now, you're intelligent young people. What happens right here? It starts again, doesn't it? Right? So I have to start again with my domain. What is this value? 0. Is it included? Yes. So less than or equal to x. Up to what? Is 30 included? So a regular arrow. How would I write that in this form? Square bracket 0, comma, 30, round bracket. Now, because there's 2 of them, and this is something that's new for most of you, we put a U in between them. Because there's two sets. There's this set of domain and then this set of domain. Everybody cool? Now, if there's two sets of domain, are there two sets of range? Probably. And then we're going to need to use this again. So let's do our range. What?
Oh, I think it's just a y.
No. It's still x's. We're still looking at x's.
Oh.
Right? Now, what's my lowest range value? Negative 20. Is it included? Because now I'm looking on the y's, right? Negative 20, y, up to what? Is 0 included? No. And then, does it start again? So I need a union. Where does it start again?
20.
No. Starts at 10.
10. Oh,
Is 10 included?
yeah, no.
No. Y, up to what?
20,
30. Is 30 included?
Yeah.
Yes. Now, how would I write that red one in the other form, in interval?
So,
Square,
negative 20. And then 0 round bracket.
U, then what?
Round bracket 10, comma 30, square bracket.
Everybody good? Easy peasy, yeah? And remember, I will tell you again, I'm not giving you any work tonight. Let's look at this one. Is it a function? Which is it, Satcho? You just keep saying yes and no.
Yes.
It is.
It is.
Do we count the bill?
Indeed not.
Yes.
That's the problem spot, right? That's what's causing us grief, yeah? So is it a function?
No. Okay, yes, because it's not filled in.
Hell yeah, bonus points for you.
Thank you.
Does that open circle exist? No. So really, it's only hitting the graph at one point, isn't it? So that is still a function. Now, let's get really tricky. What's the domain? Negative 6. Okay. Less than x. And what does it go up to? No. Because what happens at negative 3? What happens right here? It starts again, doesn't it?
Oh, so 3.
So I start here, and how far up do I go? Positive 6. Is 6 included? So what kind of arrow? The equal arrow. How do I write that in interval form? Round bracket, negative 6.
6
Square.
square.
Okay, now let's get tricky. What is the range? 3. Then what?
And then negative 9. No,
3, 6,
9.
9. Can I do the arrows or the interval here? No, because I couldn't color, could I? There were the only values allowed for y were 3, 6, and 9. So I have to do this. I can't use the arrows and I can't use the interval. Everybody cool? That's a lot of stuff today, yeah? That's a lot of stuff, but we're not going to do anything with it till tomorrow. Okay? But really, what did we bring to the party? Input, output, function relation, domain range. 5 things, yeah? All right. Take tonight off. Take the last 5 minutes off. What? You will not need a graphing calculator. But you may want, ladies and gentlemen, to have some graph paper. I will provide you with some too, just for scratch work. In your books, I give you graph paper to work with, but you may want some extra.